All right, so diagram for this question here, guys. Our first vector is 950 meters at 30 degrees north of west. Okay, so I'm going to have a line that is west. Okay, like so. I'm going to go 30 degrees north of that for 950 meters. Okay, so that's 30 degrees. That's 950 meters. This would be y, and this would be x. Okay, and then our other one is 385 meters at 45 degrees south of east. Okay, so I'm going to put that one on the head of the first. Okay, it's only about half as long as this one. Okay, actually not even half as long as this one. So we're looking at maybe a line. Sorry, it's south of east. So I'm going to draw my line east. Okay, and then I'm going to go like this. Okay, so this will be x, this will be y. This angle here is 45 degrees. That goes all the way to there. Okay, and this is 385 meters in length, which means my resultant should go like so. Okay, so your diagram should look something like that. Okay, so let's have a look at this one here. So we've got our diagram, we've got our x's and y's labeled. So our next step is that we need to calculate all of the horizontal or x components, all the vertical or y components. Okay, so we'll start out with the 950 meter long vector. Okay, so black x, which is its horizontal component, okay, is the adjacent side to the 30 degree angle. All right, so we're going to use cos for that. So we'll have the cos of 30 times the hypotenuse, which is 950. All right, so we're going to have cos of 30 times 950. All right, so that side's going to be 822.724. Obviously, we're going to keep all the decimals when we do any other calculations. That's going to be meters, and it's west. Okay, my y component is the opposite side, so it'll be the sine of 30, okay, times 950, which should be 475 meters north. Okay, everybody all right with that so far? Okay. Then we have to do the same thing with our red triangle. So red x is adjacent to the angle that I was given. Okay, so it's going to be cos of 45 degrees times the hypotenuse, which was 385 meters. Okay, so cos of 45 times 385. All right, so 272.236. meters, and that is east. Now, sometimes on a question like this one, I will give you time-saving angles. Why is 45 degrees a time-saving angle?
Because the cosine and sine of 45 degrees are equal.
Exactly. Okay. If you have a 45-degree triangle, the amount it goes over and the amount it goes up are the same because it splits 90 halfway. Okay. The two sides have to be the same. So you ever see a 45-degree angle? I'm trying to save you a little bit of time, okay, by not having to do the calculation twice. If you do it twice, you just get the same number and go, oh crap, Coder was trying to save me time and I wasted it. Okay. But now you know. All right. So the y value is going to be 272.236. Meters, and that one is south. All right, so now I've got all of those. Now I can find blue x and blue y, or my resultants triangle now. Okay, so blue x, okay, is going to be black x, which is west, plus red x, which is east. So in other words, one of them is negative. All right, so I'm going to have basically our 822.724, okay, minus 272.236, okay, and that'll give me my x component to the west. okay? And then I'll do the same thing with y, because black y is north and red y is south, so I'll have to subtract them as well. Okay, so that'll be 475 meters, okay, minus 272.236, okay, to get that one. All right, so we'll have our 822.724136, okay, minus our answer. So we're looking at 550.488 meters west. Okay, and then for our y, okay, we're going to have our 475 minus 272.236, 1108. All right, so that's going to be 202.764 meters, and that is north. All right, so looks like scale-wise, I didn't do a half bad job. Okay, my final triangle is at least approximately to scale. Okay, my x component is more than twice as long as my y component. So, okay, it's always good to know that I did a decent job and that my diagram's not lying to me. Okay, so what's my next step? Now I have the resultants x and y. Right, I find the magnitude of the displacement. Okay, remember that in this one, I am finding the displacement because I was given all displacements in there. Okay, so we'll have our 550 squared plus our 202 squared, obviously with all the decimals carried over. Okay, so we'll have our answer squared, okay, plus 550.488022.8 squared. Okay, so our resultant is 586.643 meters. Okay, now we need to get our vector. All right, that's going to be this angle here, okay, that we need to find. So I can use any trig function I want at this point, but I'm going to use tan. Okay, so tan to the minus 1 of essentially y over x for the way I drew that triangle. Okay, so that's going to be our 202 over 550, again, with all the decimals. Okay, so second tan of 202.7638892 divided by 550.488022.8. All right, so I'm getting a 20-degree angle there, 20.22 degrees. And the direction on that is going to be north of west. Okay, am I done? No. What did the question ask? They wanted to know the average velocity. Okay, so this is that last step. And guys, if I ask a question like this on a quiz, you'd be surprised how many people miss out on the last 3 marks. Okay, because they do all this work and like, oh, I'm done. And they forget, okay, that I gave them a time and asked for velocity on this. Okay, so to calculate the average velocity, okay, I need total displacement over total time. I have that, okay, it's my 586 here. So 586.643 with all the decimals, okay, divided by the total time, which was 540 seconds. Okay, so we'll take our 586.6432119 and divide that by 540 seconds. So our overall velocity is, to 2 significant figures, 1.1 meters per second at 20 degrees north of west. Okay, another place where people would lose a mark, they'd forget to put that 20 degrees north of west they worked so hard to figure out on their final answer. Okay, which means you gave me a speed and not a velocity. All right, so that would be a pretty typical quiz type question, hint, hint tomorrow. because you will have quiz on vector addition tomorrow. May not be exactly like that, but always be on the lookout for a final step. Now, a question like this is worth a ton of marks because there's a ton of steps. All right, so you're aware, just to kind of see where that breaks down. You get 1 for the diagram. Okay, anywhere where you had to calculate an x or a y component, so that's 2, that's 3, that's 4, that's 5. Okay, 6, 7, 8, 9, 10, 11, maybe even 12. Okay, marks for a question like that. All right. So, for those of you thinking about using sine law or cosine law, please let me remind you that that idea is very, very bad. Okay? For 2 reasons. That whole understanding thing, and if you screw it up, what will you get? 0 out of 12. Because you won't have any work to show me. Maybe you get 1 because you drew that picture. I don't know. But I don't want that for you. I want you to understand how it works. Okay? I want you to see all the x's and y's and how this thing is moving in a bunch of different directions. Okay? So just keep that in mind for tomorrow. All right? Questions on that one? Okay.